actually, yeah, I'm trying to fit that in as small as I can, and that was real good. We may be rewriting this one. So what we're going to do is we're going to take the number that correctly predicted purchasing a new car and did purchase it, and we're dividing it by the number of people who actually did purchase a new car. Okay? So sensitivities, we have that subset of people who we know purchased a new car. And what we're going to do is we're going to take that and divide that into the number that we predicted would purchase a new car. So in this case, this is 71 plus 44. There are 44 people that did actually purchase a new car, but we did not correctly predict that they did.
We have at the top one, the addiction cost of purchase. So
This is an and.
oh.
So in this case, this is 71 divided by 115. Or in this case, we have 61.7%. What this means is that when I am trying to predict the person purchases a new car, 61.7% of the time, I will correctly predict that person will purchase a new car. So out of those people that have purchased a new car, I will correctly predict 61.7% of those people. Which actually, if you think about it, doesn't sound real good. It's not horrible, but it's not great either. But in this case, I will only correctly predict of those people who purchased a new car, 61.7% of them. So that sounds like I'm not doing very well. So let's look at another idea, specificity. Now, specificity is, do you correctly predict that you do not purchase a new car? So sensitivity is, are you picking up the people who actually purchase a new car? Specificity is, are you correctly picking up the people who don't purchase a new car? Okay? So they're kind of flip sides of the same idea. Sensitivity is talking about, are you getting those yes responses correctly? Specificity is, are you getting the no responses correctly? So in this case, what specificity is it's the number of correct predictions of not purchasing. Okay. So it's the number of predictions that you do not purchase, but you're correct about it, divided by the number of not purchasing. Well, in this case, the number that we correctly predict do not purchase is 359. We have 359 people or households that we correctly predict will not purchase a new vehicle. overall in this case, we have 385 people that do not purchase a new vehicle. The way I get that, I should have done this the opposite way, but that's okay. So we have 359 that we correctly predict will not purchase a new vehicle. And we have, in this case, 26 that we predict will, but they don't. Okay? So those 26 are people who do not purchase a new car. So what we can do is we can just add up 359 plus 26. When we add them up, we get 385. And so in this case, we're going to take 359, divide by 385. And in this case, we get 0.932, or 93.2%. So in this case, it actually does a very good job of predicting that you won't purchase a new car. Okay? What this is saying is that when it predicts that you won't purchase a new car, 93% of the time it is correct when it says you won't purchase a new car. So it's doing actually a pretty good job of classifying those people who don't purchase. It's not quite as good at predicting the people who do purchase, but it's doing a good job of predicting those who won't. Okay? Because if it says you won't, 93% of the time, you actually don't purchase a new vehicle. Any questions here? Now, if you look real quickly, SPSS already gives you these two. Okay. So SPSS here gives us our percent correct on not purchasing a new car is 93.2, and tells us our probability that we correctly predict that you do purchase a new car is 61.7. So it is automatically giving us that information. So sensitivity and specificity we get right away. Any questions here? Well, I said there are two more things, false positives and false negatives. A false positive is that we predict that you purchase, a false positive is that we predict that you actually purchase a new vehicle when in reality you don't purchase a new vehicle. Okay? So in this case, a false positive is when we predict that you're going to purchase a new vehicle, but you don't actually buy a new vehicle. So in this case, what this is the number of people or households in this case, this is the number of people that we predict to purchase that actually don't purchase, divided by predicted by, or divided by the number of predictions of a purchase. Okay? So what we're going to do is we're going to take the number of people that we predicted to purchase that actually don't, and we're going to divide it by the total